Have you ever really stopped to think about the invisible world of power that's humming along inside the walls of your home right now? It's this whole complex system we totally take for granted, but it's got its own rules, its own dangers, and believe it or not, its own secret protectors. So today, we're going to dive into that hidden world and uncover them. Okay, picture this. You're settling in on the couch, ready to watch your favorite show. You grab the remote, hit the power button, but instead of the screen lighting up, you see a little curl of smoke coming from the back of the TV. Yikes. It's a scary thought, and it's exactly what happened to a student named Rom. That one scary moment brings up two huge questions. First, what invisible force is out there that's powerful enough to literally fry an appliance? And maybe more importantly, what are the secret guardians in our homes working 24/7 to make sure that doesn't happen to us? Well, our investigation starts right now. All right, section 1, your home's unsung guardians. We're going to start with the protectors. These little devices, tucked away in your fuse box, are designed to fight one single, very common enemy, a thing called overcurrent. So what exactly is overcurrent? Well, in the simplest terms, it's just too much electricity trying to squeeze through a wire that's not big enough to handle it. Think of it like this. A wire is a road and electricity is traffic. A little country road is fine for a few cars, but what happens if you try to divert a whole 6-lane highway's worth of traffic onto it? You get a total jam, right? Friction, chaos, and a whole lot of dangerous heat. In your home's wiring, that heat is what can melt wires and even start fires. Now, the original guardian against this was the fuse. And get this, it was invented by none other than Thomas Edison way back in 1890. A fuse is basically like a tiny, self-sacrificing bodyguard. Inside it, there's a little piece of wire that's designed to be the weakest link in the whole chain. So when way too much current flows through, that little wire heats up, melts, and breaks the circuit, cutting the power. It literally sacrifices itself to save your expensive TV or computer. But fuses are kind of old school. Today, most of our homes have a much more modern guardian, the miniature circuit breaker, or MCB. As you can see here, they're pretty different. A fuse is a one-and-done deal. It melts, and you have to go find a new one to replace it. An MCB, though, is reusable. It doesn't destroy itself. It just trips a switch, and all you have to do is go flip it back on. So how does it pull off that little trick? Well, the MCB's secret weapon is this super clever little thing called a bimetallic strip. It's just two different types of metal, say steel and brass, that are fused together. Now, the cool thing is, different metals expand at different rates when they get hot. So when an overcurrent heats up that strip, one side expands more than the other, and the whole thing is forced to bend. And it's that physical bending motion that literally pushes the switch and cuts the power. It's just a brilliant, simple piece of physics at work. So that brings us to section 2, the 3 electrical culprits. We've met the guardians, but what exactly are they protecting us from? Let's meet the 3 main troublemakers that are responsible for causing overcurrent in the first place. First up is the overload. Now, this is the most common culprit, and let's be honest, it's something we've probably all done. It's when you just ask way too much from one single circuit. You picture that power strip under the desk trying to run your computer, your monitor, a little space heater, and charge your phone all at the same time. Every single one of those devices is pulling power, and all together, they can demand way more current than the wiring was ever built for. That's what leads to that dangerous overheating. Culprit number 2 is the short circuit, and this one is way more dramatic. It happens when the insulation on wires gets old and cracks, and the live wire and the neutral wire actually touch each other directly. This creates, well, a shortcut for the electricity to flow, and with almost zero resistance in its way, the current surges to absolutely massive levels, like instantly. That creates intense heat and sparks that can easily start a fire. It's like a sudden, explosive failure happening right inside your walls. And finally, we've got the ground fault. Now, this is different. This one is all about electricity escaping the system entirely. It could happen if a live wire comes loose inside an appliance and touches the metal casing. The electricity is now trying to find the quickest path to the ground. And if you happen to touch that appliance, you become that path. This is the culprit behind most of those really nasty, dangerous electric shocks. Okay, on to section 3, the heart of the machine. So we've got the culprits and we've got the guardians. But who's the victim caught in the middle of all this? Well, more often than not, it's the hardworking heart of our appliances, the electric motor. Think about it. Almost everything in your house that moves, spins, or vibrates has an electric motor inside. Your fan, your blender, your washing machine, they all have one. It's this amazing component that turns electrical energy into actual motion. But the delicate little copper wires coiled up inside are super vulnerable to all that heat from overloads and short circuits. So how does electricity even make something move? It's all because of a cool physics principle called Fleming's left-hand rule. Basically, if you pass an electric current through a magnetic field, it creates a physical force. You can even see it with your own hand. If your forefinger is the magnetic field and your middle finger is the current, your thumb shows you which way the force, or the motion, is going to go. It's this simple, interconnected relationship that makes every motor spin, and it's exactly what's at risk during an overcurrent. And that brings us to our last section, Section 4, the Technician's Toolkit. When these invisible forces do cause a problem, how does a technician even begin to diagnose it? Well, they rely on a special set of tools to make the invisible visible. I mean, that's the real challenge, right? You've got a problem, but the cause, the flow of current, the pressure, the friction, it's all completely invisible to the naked eye. So how do they solve the mystery? They use a gadget called a multimeter. You can think of it as a detective's most important tool for electricity. It measures three key things. First, voltage, which is kind of like the electrical pressure in the system. Second is current, that's the actual flow of electricity. And third is resistance, which you can think of as electrical friction. By measuring these three things, a technician can basically see inside a circuit and figure out exactly where the problem is. So let's just pull this all together. Your home is filled with this invisible dance between really powerful forces. Overcurrent is the big danger. Fuses and MCBs are the guardians standing watch. Overloads, short circuits, and ground faults are the culprits trying to cause trouble. The motors in our stuff are often the victims. And cool tools like the multimeter are what let us become the detectives and solve the case. You know, every time you flip a light switch, you're tapping into this incredible hidden world. It's a whole system designed for your safety, full of silent protectors, all governed by the basic laws of physics. So now that you know a few of its secrets, what's one thing in your home, maybe that really crowded power strip or that old fan that makes a buzzing noise? What's one thing you'll look at just a little bit differently?